So, today we're going to pull back the curtain on a famous data detective, the a priori algorithm. It's this really cool technique for finding the secret patterns that are hidden in plain sight all around us, usually buried in just massive amounts of data.
And it all kicks off with this legendary, almost mythical question: what on earth is the link between diapers and beer? I mean, this one question basically kickstarted the entire field of what we now call market basket analysis. It sounds totally random, right? But as you're about to see, there's a powerful logic hiding just beneath the surface.
All right, so think of this as our crime scene. You've got millions of shopping lists that look completely random, just a chaotic jumble of data. But buried somewhere inside this mess are clues, these secret patterns of what people buy together. The whole trick is just knowing how to find them.
And yeah, that really gets to the heart of the mystery, doesn't it? With thousands of different products and millions of transactions, how can we possibly find the items that are frequently bought together without getting totally lost? How do we find the signal in all that noise?
Well, what our data detective is really trying to find are these things called association rules. They're simple but incredibly powerful statements, just like this one. Finding these rules is like discovering the unwritten laws of how customers behave.
Now, any good detective needs a toolkit, right? Well, in data mining, our tools are metrics, ways to measure if a clue is a real, solid pattern or if it's just some random coincidence. Let's take a look at the three most important ones.
The very first question our detective has to ask is super basic. How popular is this clue? Are we looking at something that happens all the time, or is this just a rare, one-off thing? We've got to focus on what's common.
And that's where our first tool comes in. It's called support, and it's really just a measure of popularity. By setting a minimum support level, we can just filter out all the rare stuff and focus only on the combinations that show up frequently. It's our first and most crucial step to cutting through the noise.
Okay, so once we know a combination is popular, we have to dig a little deeper. The next question is all about reliability. If a customer picks up item A, how often does that actually lead to them also grabbing item B?
And that brings us to our second tool, confidence. Confidence measures the strength of that connection. So a high confidence score, like the 75%, tells our detective, hey, this is a really reliable clue. When we see diapers, there's a very, very good chance we're going to see beer too.
But wait, there's one last and honestly super important check we have to make. Is this pattern genuinely special, or is it maybe just happening by random chance? For example, think about bread and milk. Do people buy them together because there's a real link, or just because, well, everyone buys bread and milk anyway?
And that's where our final tool, Lift, saves the day. Lift is the ultimate test. It tells us how much more likely two items are to be bought together compared to just pure chance. A Lift score greater than 1, well, that's the smoking gun. That's the proof that our pattern is real and actually significant.
Okay, so we've got our tools. We know how to measure clues. But how does the algorithm itself, the detective, actually sift through millions and millions of possibilities? Well, it uses a really clever strategy to work smarter, not harder.
I mean, look, if you tried to just brute force it, test every single possible combination of items, a computer processing a modern supermarket's data would be running for ages. It's basically impossible. The absolute genius of a priori is that it sidesteps that whole mess. It intelligently prunes or gets rid of combinations it knows are just dead ends.
And the secret to how it does this, its secret weapon really, is something called the a priori principle. It's such a simple, elegant piece of logic. It just says that if diapers, beer is a popular combination, then diapers by itself has to be popular too. And the flip side is also true. If, say, pickles isn't a popular item on its own, then there's no way any combination containing pickles is ever going to be popular. This one idea allows the algorithm to just instantly eliminate millions of possibilities.
So the whole process breaks down into 4 pretty clear steps. First, we set our standards. That's the minimum support and confidence we'll accept. Then, using that powerful a priori principle, it finds all the popular item combinations. From there, it generates our rules, and finally, it sorts them by lift to find the most powerful insights hiding in the data.
Now, to make all this happen super fast, the algorithm has a couple of secret weapons working under the hood. A systematic way to search for things called breadth-first search, and a super fast way to count them called a hash tree.
Here's a really great way to picture this. The breadth-first search is like organizing a library shelf by shelf. You start with single popular items, then you look for popular pairs of items, then popular trios. You build up systematically level by level. And the hash tree, that's your super detailed card catalog.
Instead of wandering through the whole library to find a combination, it tells you exactly where to look, making the whole counting process incredibly fast.
Right, so this is so much bigger than just supermarkets. This whole idea of finding hidden patterns, it's being used to solve some really important puzzles out in the real world, far, far beyond the grocery aisle.
I mean, think about it. In healthcare, this could find dangerous drug combinations that cause serious side effects. That people who bought this also bought feature on your favorite shopping site, yep, that's this algorithm at work. Banks use it to spot weird patterns that could be fraud, and websites use it to figure out how we navigate through their pages, helping them improve the whole user experience. It is everywhere.
So if we just strip away all the fancy terms for a second, what's the big secret here? What's the core idea? Well, it turns out it's something you and I already do all the time without even thinking about it.
It's really as simple as this. Just imagine you're throwing a party, right? And you notice that every time someone grabs a handful of chips, they almost always go for a soda next. So what do you do at your next party? Well, you put the sodas right next to the chips, of course. You just use the exact same fundamental logic as the a priori algorithm. You found a pattern and you acted on it.
And that's really the big takeaway. These hidden patterns, these association rules, are constantly influencing our world, from the layout of the store we shop in to the recommendations we see online. So the final question I want to leave you with is this. Now that you know how it works, what are the hidden patterns out there that are shaping your world?